Okay, so let's start. So today I am going to discuss organic chemistry topic, that is resonance, which is a very important one. Resonance is also known as conjugation. And conjugation, or there is a one more thing, that is delocalization of pi electron. So resonance is also known as conjugation and also known as delocalization of pi electron. What we have to cover in this topic, we will first check how you can find resonance in the compound, means identification part. And after this, I will discuss pi electron and then resonance structure. And in the last, we will discuss stability of resonance form. So these four topics we have to cover, which is related with the resonance. Now I'm going to start with the identification part. If you want to write, you can take the screenshot. Perfect. Now we can move. The one is identification. Suppose you have a positive charge, you have a negative charge. This is known as radical. This is known as radical. This is lone pair. And double bond. And last option is vacant orbital. Generally, in case of vacant orbital, boron is a very common one. Boron and sulfur. Aluminium as well. But out of these three, boron is most important. So these groups are known as positive, negative, lone pair, radical, double bond, and vacant orbital. They are treated as conjugate species. Conjugate species means the species which is responsible for resonance is known as conjugate species. So means these species, positive charge, negative charge, radical, lone pair, double bond, and vacant orbital, it can show resonance or conjugation. Now I will check how you can apply this information. Suppose you have a compound CH2 plus CH double bond CH2. We have this compound and we have no idea about resonance of in this compound. So how can you check resonance in this compound? First of all, you will have to assume every conjugate species, positive charge or negative charge or radical or lone pair or double bond or vacant orbital, every conjugate species as a double bond. You will have to assume this one as a double bond. And after that, you can check double, single, double pattern. If double, single, double pattern is present in the molecule, then we can show it will show resonance. If this pattern will not follow, then we can't say resonance is there. Okay. Suppose like this, we have a compound and you can see here, this is a positive charge. It means it is a conjugate species. And you can assume this one as a double. So after assuming this one as a double, you can see double, then single, and again double is coming. double, single, and double. It means double, single, double is following here. So we can say it will show resonance. It will show the resonance because it has a double, single, and double. Listen me again. I am saying the species which is responsible for resonance is known as conjugate species. And conjugate species are positive charge, negative charge, radical, lone pair, double bond, and vacant orbital. So you will have to assume each conjugate species. It may be positive, it may be negative, it may be radical, it may be lone pair. You can assume every conjugate species as a double bond. And after that, you can check double, single, and double. If double, single, double is there, then you can say it will show resonance. And you can see here we have a positive charge. So you can assume this one as a double, and double, single, and double. Any doubt? Please tell me. I will discuss few more example. Any doubt about this one? When I will discuss few more example, it will make more sense to you. Don't worry about the examples. Any doubt about this one? Please tell me. Any doubt? Okay, no doubt, no doubt, no doubt, no doubt. Perfect. I can tell you again, listen. First of all, these are the conjugate species: positive, negative, radical, lone pair, double bond, and vacant orbital. Means it will show resonance. So if any compound is there, then first of all, you will have to assume every conjugate species as a double bond and check double, single, double. If double, single, double is there, it means it can show resonance. Suppose we can take this one. Okay, I told you that positive charge, negative charge, radical, double bond, vacant orbital, and lone pair. Whenever is there, you can assume everyone as a double bond and check double, single, double. So this is a positive charge. So you can assume positive as a double. So double, single, and again double is coming. It means A will show resonance. This time we have a negative charge. So you can assume negative also because negative is also here. So in negative also you can assume double. So double, single, and again double. So it will show. And third one is your lone pair. Lone pair is also present here. So you can assume lone pair as a double, double, single, and again double. So it can show. And D, it is already double. So there is no need to assume this one as a double. So double, single, and again double. It will show. Any doubt? Please tell me. Is there any other resonance that does not apply like this? No, mainly 99%. 99% you can apply this rule. 1% is always an exception in a chemistry. So most of the examples will fit in this type of, trick. Let me know about this one. Which will show resonance. Tell me A, B, C, D, which one will show resonance? Okay, one by one. Let A, yes, yeah, no. A. A. I am just talking about A. A will show yes or no. Yes, A will not show. Very good. Perfect. What about B? Yes or no? Very good. B, yes, yes, yes. This part, this zone is a resonance zone. Okay. What about C? Wait. C. C. Yes, C will not show. Double, single is there. Double, single is there. No resonance. D, yes or no? D. Very good, Amina. D. Yes, this time boron has a vacant orbital. I told you that. Negative, positive, lone pair, radical, double bond, and vacant orbital. So boron is an example of vacant orbital. So you can assume boron as a double and check double, single, and double. So D will show. What about E? Listen, Lally, this is a crash course. I can inform you why boron is a vacant orbital. It has a vacant orbital, but it will be good for you to memorize boron as a vacant orbital. But I can tell you if you will contact me after this class. Otherwise, it will take 15 to 20 minutes less more extra time to describe boron as a vacant or not. So you can contact me after this class. I will definitely clear this concept. But you can memorize boron has a vacant orbital. What about E? Yes, E will show because lone pair is there. So you can assume lone pair as a double bond. So double, single, and again double. It makes sense. So you can identify your resonance in the compound in this way. Very easy and very tricky. Double, single, double. Positive, negative, radical, lone pair, double bond, and vacant orbital. These species can take part in resonance. Okay, now we can move to the pi electron. Can you please explain about what we should know about resonance? What does it, when it does occur? Listen, I will show you what the role of resonance in your syllabus or questions when I will start questions, because I already told you that 4 topics is related to the resonance. First, identification, and it is not necessary that identification can come in your exam, but it is related. It is related to the next topic. Okay. So after identification, the pi electron, and then the resonance structure. So role of resonance is important in resonance structure. So when I will complete this topic, then it will make more sense to you and you can, easily solve your questions. So now we can back to the pi electron. Pi electron is of 2 types: conjugated and non-conjugated. Conjugated means resonance, like delocalized is also known as, while non-conjugated is localized. And there is a additional information: if negative charge is there, that will give you 2 pi electron. If lone pair is there, that will give you 2 pi electron. And double bond is there, that will give you 2 pi electron. But if you have a positive charge, it will not give any pi electron. Vacant orbital will not give any pi electron. Suppose we have this compound. And my question is, how many conjugated pi electron and non-conjugated pi electron? So if you look at this compound, you can see the resonance is present only with double bond, means these two double bond is a part of resonance, while this lone pair is not the part of resonance, because you can apply double single double concept. So double bond is a part of resonance. So we can say they both double bond is your conjugated. They both double bond is your conjugated. And this lone pair will be treated as non-conjugated. And you know that lone pair will give you 2 pi electrons. So non-conjugated is 2 pi electron. While they both double bond is your conjugated, and that will also give you 2 pi electrons. So overall 2 from here, 2 from here. So conjugated is your 4 pi electron. It makes sense. The conjugated and non-conjugated pi electron. The species which are in conjugation, that is taken as conjugated pi electron, and the species which is not in conjugation, that will be treated as non-conjugated. Simple. And you will have to memorize negative will give you 2 pi electron, lone pair will give you 2 pi electron, and double bond will give you 2 pi electron. Any doubt about this one? Please tell me. Yes, conjugated means resonance containing pi electron. Yes. Any doubt, please tell me. No doubt. Okay, we can move to the next. Some more example. Okay, suppose we have this one. A, B, C. How many conjugated pi electron in A? Conjugated pi electron as well as non-conjugated pi electron in A. Tell me. First of all, check your resonance. If resonance is there, means that species is showing your conjugation. And you can check your resonance very easily, double, single, double. Yeah, it has more than one resonance, means lone pair as well as double bond, both are in resonance. So what will happen? Listen, this is lone pair. You can assume this one as a double. So double, single, and double. It means lone pair is your conjugated. And both double bond is also conjugated, because double, single, double is also here. So if you are going to calculate your pi electron, so you can see lone pair will give you 2 pi electron. Double bond, that will also give you 2. So overall you have 6 conjugated pi electron, and their non-conjugated will be 0, because we have no species which is non-conjugation. Any doubt about A? Lone pair, both double bond, all are in resonance. So that's why it has 6 conjugated pi electron. My request to everyone, please respond me. It makes sense? Perfect. What about B? How many conjugated and non-conjugated pi electron in B? Listen, pi electron and sigma electron, two type of electron is present in any compound, but in resonance only pi can take part. As you can see, in resonance single bond is not taking part. So whenever you have a pi electron, means it can be present in double bond, it can be present in lone pair, and it can be present in negative charge. Pi is a electron rich species, electron rich. It has more electron. So it can take part in resonance. That's the mean of pi electron. Okay, now in B you can see double bond and this double bond and positive charge. This is also in conjugation, but positive has 0 pi electron. And this 2 double bond will give you 4 pi electron. So you can say conjugated will be 4 pi electron and a non-conjugated will be 0. Any doubt about B? What about C? How many conjugated and non-conjugated pi electron? What about C? Count the conjugated and non-conjugated pi electron. Yes, listen. If you are going to check your resonance, negative and they both double bond, they are all in conjugation. So each will give you 2. So overall you have 6 pi electron that is conjugated. And non will be 0. Any doubt? Perfect. Now we can move to the next. Here few note points. I just want to clear this one. Note number 1. If any atom has more than one lone pair, then only one will take part in resonance. Rest of the lone pair will be non-conjugated. Suppose you have A having two lone pair and it is a part of resonance. You can see here double single double is present. So in case of A, any one lone pair can take part in resonance. It may be up, it may be left. There depends on you. Suppose this is conjugated, then this lone pair will be non-conjugated, and this double bond also in conjugation. So overall conjugated pi electron is 4 and non-conjugated is 2. Any doubt about this one? The note point. Okay. What about this one? How many conjugated and non-conjugated pi electron? Yes, it will be 6 conjugated and 2 non-conjugated because this oxygen has 2 lone pair. So out of 2 lone pair, only one will take part in conjugation. This will be non-conjugation. And this is double bond. They both are in conjugation. So overall, you can see 6 pi conjugated, 2 pi non-conjugated. Any doubt? Please tell me any doubt. Perfect. Now we have another note point, note number 2. If any atom has more than one, sorry, if any atom has lone pair as well as double bond, then double bond will take part in resonance, while while lone pair is treated as non-conjugate. Lone pair is treated as non-conjugated. Like this. Suppose you have a lone pair as well as double bond. You can check here. First of all, apply double, single, double concept. Suppose this is double or lone pair or double, you can assume anyone. Double, single and double. It means this compound has resonance, but A has both lone pair as well as double bond. So if A has both, then only double bond will take part in conjugation, while lone pair is treated as non-conjugated. So you can see you have 4 pi electron as conjugated and 2 pi electron as non-conjugated. Any doubt? Please tell me. Perfect. Okay. What about this one? How many conjugated and non-conjugated pi electron? Tell me. Very good. You guys are really very quick. Yeah, 6 conjugated and 2 non-conjugated. 6 conjugated and 2 non-conjugated. You can see here. This nitrogen has lone pair as well as double bond. So double bond will take part in conjugation. This lone pair is a non-conjugated, and they both double bond also in conjugation because you can apply double, single, double. So conjugated, conjugated. So now you can see you have almost 6 pi electron as a conjugation and 2 pi electron as a non-conjugated. Any doubt? Perfect. So this is pi electron and identification part. Now the rest is resonance structure and stability of resonance form. So before resonance structure, I just want to clear the stability of resonance structure, because stability of resonance structure is a very important part. So now I am going to discuss stability of resonance form. Okay, let's start with the resonance structure. Otherwise, you will say why it will form this structure. So let's start with the resonance structure. Resonance structure is also known as canonical structure or contributing structure as well. So there is a 6 type of resonance structure. First one is positive charge with double bond. Second one is negative with double bond. Third one is lone pair with double bond. Fourth one is radical with double bond. Fifth one is double bond with double bond. And sixth one is back bonding. What is back bonding? Back bonding has two conditions. When lone pair in its presence, lone pair is present in adjacent of positive charge. This is one type of back bonding. And when the lone pair is present any vacant orbital containing atom, means in adjacent of vacant orbital. So there is a two condition in which back bonding can take place. And this is all the type of resonance form. We will start from this one and then this, like this. Please take the screenshot of this. Perfect. First start with double bond with positive charge. Listen me. Suppose we have a positive charge and it is in double bond with C, like resonance. So resonance structure is separated by double-headed arrow, this headed arrow. And in resonance structure, you will have to break your double bond. The first thing is that break double bond. And the head of this arrow is very important. The head of arrow means negative charge and tail of arrow means positive charge. Head and tail is very, very important. So the rule is here, break double bond in such a way opposite charges must be in adjacent position. This is supposed to be 1, this is supposed to be 2, this is 3. So you can break your double bond in two ways. One in this way and one in this way. Means head of arrow on B or head of arrow on C. There is only two possibility where you can break your double bond. So as you can see, the head of arrow means negative charge. Head of arrow means negative charge and tail of arrow means positive charge. So if you look at top arrow is indicating that B will take negative, while bottom arrow is indicating that C will hold the negative charge, because head of arrow on C in the bottom one, and in the top one head of arrow on B. So tell me which bond representation is correct, top or bottom? You can indicate like T and B. T stands for top, B stands for bottom. Tell me which arrow we can use. The point is here, opposite charges must be in neighboring position. Opposite charges must be in neighboring position. Listen, this is my arrow. So this arrow is head position, which means negative charge. And this is the tail position, which means positive charge. So we have to keep opposite charges in neighboring position. Tell me. Yes. Yes, top one. Top one will be correct one. B, the bottom one is a wrong one. You know why? Listen me again. I will write again because someone has confusion. Suppose A positive, B double bond C. We can use this arrow and we can use this. I will tell you which one is correct, which one is wrong. And head of arrow means negative charge, tail of arrow means positive charge. And the rule is keep opposite charges in neighboring, opposite charges in neighboring position. Means suppose this is 1, this is 2, this is 3, 1, 2, and 3. So now you can see if you look at X, here 1 and 2 have opposite charges because B has head of arrow, which means negative. And if you look at Y1, here A has positive, but B has a tail of arrow. Definitely tail is present mid of the bond, but it is indicating towards B. As you can see, head is present on C. But in example Y, tail of arrow is present on B. Tail means positive charge. So B has same charge, positive, and A also have positive. So it means repulsion. So Y is not correct. Any doubt about this one? Why X is correct? Because 1 and 2 have opposite charges. Please tell me. Any doubt about this one, the bond breaking phenomena? Okay. So now we will proceed from bond breaking. Suppose we have A bonded to B, B bonded to C, and we are using a positive, and arrow will break like this. 1, 2, and 3. In a resonance structure, the basic structure will never be the change. Means the connectivity means A bonded to B, B bonded to C. It will be the same, and that should be 1, that should be 2, that should be 3. I told you arrow representation, head means negative, tail means positive. If you look at number 3 position, number 3 carbon, it has, sorry, this is alphabet C. Number 3 has tail of arrow. Can you see tail at number 3? So tail means positive charge, so tail will hold positive. And now you can see 1 and 2. 1 has positive, B has head of arrow means negative. We will assume as a negative, we will not write over negative here. Okay, head of arrow means negative. So as you can see, opposite charges will always be attract. Suppose A has positive, B has negative. So there will be attraction between them and they will form a bond like this. If they have already a bond, then again there will be a bond, that is double bond. So same thing will happen here. A have positive, B has negative, so there will be attraction and there will be a bond. And now you can see this is the resonance structure of this. It makes sense to you? Tell me please. I will do one more example of positive charge. Yes, I will do plenty of examples. Don't worry about examples. Suppose this one. First, start numbering from positive to double bond. 1, 2, 3. Use double-headed arrow. Basic structure will not change. 1, 2, 3. Now what will happen? Break your double bond. Double bond should be like this. And I can tell you a trick as well. Whenever you have a positive charge, the arrow head towards the positive charge in the neighboring atom. Means it should be like this. So that's why the head of arrow on 2, because 1 has positive charge. So now the thing is very easy. 1 and 2 have opposite charges. You can see 2 has head, which means negative, 1 has positive.